Welcome in, everyone. Hello, hello. Happy Wednesday. I hope everybody's having a great week so far. We are going to be doing exponential equations today. So if you know anybody struggling with Algebra 2, exponential equations, solving them, this is a live for them. Can you double tap your screen? Let's get to 1K likes. And yeah, let's start. So the first one, number one, says solve for x. They give us the powers with like bases. So there's an exponential rule that says if you have the same base, you can set the exponents equal to each other and then solve. So since this is a base 8, this is a base 8, we could do 2x minus 1 equals 3x minus 7. Same base. Okay, that's the same base rule. All right. Now this goes back to our solving equations algebra. We want x's to one side. So we're going to, usually I will put the x's on this side, but I'm going to move this 2x this time. Why I'm doing that is because I don't want it to deal with any negatives on the x. So now that I did that, what do I have to move next? Let me see it in the chat. What do we have to move next if we want x by itself? Raven, this is Algebra 2. Algebra 2, and we're doing exponential equations. Jose said add 7. Bridget said add 7. Wonderful, you guys. Yes, Rated said add 7. So we're going to add 7 to both sides. And then we get x equals 7 minus 1 is going to give us 6. And that's our first answer. Okay, so we love it when they give us same base. It's really kind of goes back to like Algebra 1, right? We love it. So here we have same base as well. So we're going to set this up as x plus 4 equals 11. We need x by itself. So we're going to subtract 4 to both sides. And we're going to get x equals 11 minus 4. That's going to give us 7. And that's our answer. Okay, any questions on the first two where you have the same base? Any questions? Now, this is what you should be learning right before you have logs. Oh, sorry. Oh, sorry, I missed the question. Let me scroll back down. Somebody said, do you have worksheets like this for your math classes in a website or something? No, I don't have these worksheets, but I do put the worksheets that I make, I do put them on my website. But I just Googled this real quick and then printed this off. So you should be able to find this on Google. All right, let's keep it pushing. So number 3, now we're going to do for powers with different bases, okay? And the thing you have to know about this is you have to be really good with your like changing them into the same base. Okay, so here we have to think this is going to be 2 to the what power? So how many 2's does it take when you multiply 2 times 2 times 2 times 2 times? How many does it take to make 8? Let me see it in the chat. How many 2's does it make when you times 2 by itself? How many times do you have to times 2? Jose said 3. Bridget said 3. Beautiful. Ahai said 3, 3. Wonderful, you guys. It is 3 2's. Because, okay, so for those who, 2 times 2 times 2, well, this is going to give us 4. And then if we drop down that 2, 4 times 2 gives us 8. So that's why it's 2 to the 3rd. And now that we have the same base, right, we can write our equation. X plus 3 equals 3. And then we're going to subtract 3, and we get x equals 0. And that's our answer. If you're like, if you saw it right away, like if you just saw, well, 2 to the third, right? We saw 2 to the third. So really, if you would have said, what was x? I mean, it's always different ways on how you could have looked at it, right? So let's go down. Let's work down. Okay. So we have a base 4 here. Okay. So I'm going to keep this 4 here. Okay. I'm going to keep that the same. So then I have to say, how many 4s am I multiplying to get to 16? Let me see it in the chat. Thank you, still standing. 2. Tim said 2. Wonderful, you guys. Yes, 2. So we have 2 4s because 4 times 4 gives us 16. Now that we have the same base, we could set our exponents equal. So we could do 3x minus 1 equals 2. All right. What are we moving first? What are we moving first? Hey, Jay. Minus 1, plus 1, minus 1, plus 1. Ooh, what we saying? Are we minusing or are we adding? Now, remember, we have to do the opposite when we're moving it over. So we're going to add 1 to both sides. And this becomes 3x equals 2 plus 1 is 3. Okay, we're going to divide, and x equals 1. And that will be our answer. Okay, now it's getting a little spicy, right? With the 1/2, does anybody know how we can make this 1/2 into a power of 2? Can you put it in the chat if you know? Thank you, Elizabeth, for sharing the live. Thank you, EXO, for the good. -1, multiply, convert to a decimal, flip the reciprocal. Okay, so I love all of these inverses. So I love when somebody said, let's flip it to a reciprocal, right? But if we remember your rule, your exponent rule, if you move this up, right? If we move this 2 up, then we're saying that this is really a -1. Because 2 to the -1 is going to give us 1/2. Any questions just on this part? Because you gotta understand that. Because it's just going to get worse and worse. This is like the more fractions we do. If you got to understand this part first. Any questions on that part? Yes, explain again, please. Yes, okay. So there's a rule that says, usually we always try to get rid of negative exponents, right? And how we get rid of negative exponents is we put the 2 in the denominator and then we slap a 1 on top of it. Well, if we want to go backwards in order to move the 2 back up, then it's going to be 2 to the -1 power. Hey, Betty. Hello, hun. Okay. Yes, Chef Chris. Yes, please. Email me. If you're looking for tutoring, you guys can email me at impactmath19@gmail.com. Okay. And then if you're looking for this live, post it on my YouTube. Follow me over there at impactmath19. Okay. So let's continue. So we're going to put equals 2x plus 2. Okay. Now that we have the same base, we can set these exponents equal. So we can say x plus 2 equals -1. All right. Now we want x by itself. So we're going to subtract 2 to both sides. Can you guys tell me what the answer is? What do we get when we do -1 minus 2? -3. Good. 0, -3. Good. Yes, we get -3. Somebody owes you $1. And then they say, let me get 2 more. Well, they're going to owe you 3. Wonderful. Okay. All right. All right, let's go to the next. So we have 36. Thank you for the double taps, you guys. Okay, remember, you're thinking, how many 6s do you have to multiply to get you to 36? You guys are already saying it? 2. So now we have 6 to the 2 minus x. Now, just by this setup here, does anybody see what x has to be in order for this to be true? Just by looking at this part, can you see the answer? Yes or no? Put it in the chat. Yes or no? 0. 0. Good, Ed. 0, 0. No. Yes. Good. Okay, because especially you want to save time, right? We don't want to take the time to have to write this out like this. When we see, if we look here, see how we have 6 to the second and then we have 6 to the second? That means this has to go away. So really, I'm going to show you, we'll solve it out for those who don't see it, but x does have to be 0 like you guys were saying. Okay, we want to move a +2. So we're going to subtract 2 to both sides. Then we get -x equals 0. Are we done here? Is this considered done? Yes, I do GED. We did that on Monday. I just put it up on my Impact Math on YouTube, the live. No. Good. X can't be negative. Yes, Jave. X cannot be negative. So we have to divide here by -1. And then we're going to be x equals 0. And that is our answer. Go ask Daddy, okay? Okay. So now this one is a hard one. It's like, oh, we don't have the same base. How can we make 1 be the same base as a 3? All right, this trips a lot of people out because it's like, what? But if you have to know an exponent rule here. Does anybody know what that exponent rule is? 1 to the power of 3. Oh, thank you so much for the dolphin pillow head. Thank you. Okay, so you said 1 to the power of 3. Let's talk about that. 1 to the power of 3. Well, 1 to the power of 3 is 1 times 1 times 1. But the problem is I need a base to be 3, not the power to be 3. So that's why that does not work. But great thinking. 3 to the power of 0. Yes. Raina said 0 to any power is 1. Perfect. So 3, we're going to drop this down, and then we could get 3 to the 0 power. And anything to the 0 power is going to give us that 1. That's why we can write this as 3 to the 0 power. Now that we have the same base, we can solve. We can set our exponents and set them equal. We're going to move this +1 to the other side. And we get x equals a -1. And that will be our answer. Any questions on this? Farsal said, oh, interesting. Okay, I see. Good, Bridget. Thank you, Elle, for the follow. All right, let's keep it pushing. Okay, so I was doing this in calculus last semester. Ooh, Lulu, bless your heart, calculus. I remember the days. Thank you for the gift. Thank you. Thank you. All right. So now we have 1/9. Okay. Remember, we need to change this 1/9 into a power of 3. So let's break this down. This really is 1/3 to the what power? In order for us to get 9, what power is that? So now we can't do the reciprocal. Oh, I want to explain that. 3 to the power of -2. Good. Okay, 2. Okay, good. It's a power of 2, right? So let's talk about, I'm going to explain why we can't do the reciprocal so everybody can understand that. But let's finish this out. So now we have 1/3 to the second power. Remember, when we move this up, this +2 has to go to a 3 to the -2. Because whenever you want to move a positive exponent up, it goes to a negative. That's an exponent rule. So let me stop there. Let me see if anybody has any questions just on this part. Oh, I go live Monday through Saturday at 1 p.m. Central Time. I'm trying to stay consistent. I've been on my consistent journey. Why is it 2 again? Maria, is 2 again because 3 times 3 will give us 9. So that's why we have to have to the second power, because it's 3. This second power means 3 times 3. How many times you multiply 3 to itself? Great question. Yep, Kiki. Okay, perfect. All right, so now somebody said, can we do the reciprocal? So I want to explain to you why the reciprocal doesn't work. Okay, just real quick. So if we have this 3, 4 over x equals 1/9. Okay, we do the reciprocal. Remember, reciprocal means we're flipping, right? So we're going to flip this. Really, dude? That's my little one, you guys. To 9/1. So we're going to do that to 9/1. Okay, here you go. So we flip this. Well, what's the flip of this? Remember, everything can be written over 1. Okay, thank you. And so we'll put 1, 3, 4 minus x. That makes it worse. Because now how are we solving it, right? That's why the reciprocal doesn't work. Okay. Give me just a second. So you guys try to get the answer to number 8. Okay, hopefully somebody came out with the answer. So I'm going to show it right now. 4 minus x equals -2. So we want to move this +4 to the other side. So we're going to subtract 4 to both sides. We're going to drop down our -x. And -2 minus 4 is -6. Somebody owes you $2. They say, let me get 4 more. Okay. They're going to owe you 6. Remember, this is a -1. So we're going to divide. x equals 6. And that's our answer. 4 minus 6 is going to get us that -2. All right. Great job, everybody. Let's keep it pushing. Let's keep on practicing these, okay? Okay. All right. So let me scoot the paper down so it can show up. All right. So now we have 3 times 2 to the x equals 48. Good. Somebody said, I almost got it. I love it. Okay. But as long as you make the mistakes now here, that way you don't have to make them on the test, right? Figure out what you did wrong and all that. What times do I go live? Lulu, I go live at 1 p.m. Central Time, Monday through Saturday. All right. So what can we do with number 9? What's our first step? What are we doing first? Does anybody know? What are we doing first? 3 times 2? Okay. And most people would say that. So I'm glad you're saying that now. But the problem is we can't do 3 times 2 because it has this exponent of x on it. So that's what's jacking us up, because in order of operations, exponents come before multiplication. That's why we cannot multiply this, because of this x exponent. But we can undo the multiplication by dividing by 3 first to both sides. And then that isolates the 2 to the x by itself. Does that make sense? Yep, PEMDAS, yep. Good, so 48 divided by 3, isn't that 16? So why 3? Because it was 3 times the 2 to the x, so we wanted to get rid of the 3 so the 2x can be by itself. Oh, okay. Good. Great questions, you guys. So now we have 2 to the 4th equals 16. Remember, we need the same base here. Somebody said, but in PEMDAS, multiplication, it's first. Not before that E that says exponents. So exponents, because this is an exponent, comes before multiplication. That's the E part. So now the 16 will be 2 to the 4th. Yes, Maria, let's go. So we can't divide by 2. You can never divide this by 2 because of the exponent. See, the only time you can divide by 2 if it's 2x and they're multiplied together, because undoing multiplication is division. That's when we can divide. But this is not multiplying. This is saying that it's 2 to the power, or 2 to the x power. So like Maria said, she said it's going to be 2 to the 4th power here equals, we're going to drop this down, 2 to the x. And now that we have the same base, we set our exponents equal. So x equals 4. And that is our beautiful answer. Oh, I get it now. Good, Naya. Okay, I see where I'm getting confused. It's square root, right? It's not quite, because I don't want to say yes to that, because if I'm square rooting, right, that's going to give me a 4. That equals 4. Not 2 to the 4th. So how you're thinking about this power is, how many 2's do you have to multiply to itself to get this number up here? Well, you're multiplying 2 times 2, which is 4. If you times that by another 2, that's 8. And if you times that by another 2, you get 16. So if you have a calculator, in order for you to figure this out, I would just start multiplying 2 to itself. And then but you have to keep track of how many 2's, right? You're multiplying to get to this number. Does that make sense? Oh, thank you, honey. Okay, thank you, Joanne, for the follow. All right, let's finish out this top one, and then we'll move down to the other stuff. So where did the 4 come from? The 4 came from knowing that 2 times 2, it took how many 2's to get to 16? Well, it takes 4 2's. It takes 4 of these 2's. 1, 2, 3, 4. 4 of them to get 2 to the 4th power equals 16. That's what I'm trying to say. Okay. Let's try another one. Okay, so we have a base of 2. Now this is already ugly, right? Like, oh no, they did not. 2 to the third, right? But let's not even focus on that ugliness. Remember, we just want 8 to be the same base as 2. So just take this 2, and then you're asking yourselves, how many 2's are you multiplying to get 8? That's it. So put it in the chat. How many 2's are you multiplying to get to 8? 3, 3, 3. Don't drop out. 3, 3. Good. Yes, 3, 3. No, it's 3, because let's talk about that. Remember, 2 times 2 was 4, and then we multiplied another 2 and got 8. So it was actually 3 2's. 1, 2, 3. So we will put 2 to the 3rd power. Now, we wish we could just forget about this 2/3, right? But no, we still have to keep it 2 to the 3rds. And we're multiplying this up here because it already had a 2/3, okay? That's why we're multiplying. And we're going to drop down this side. 2 to the 3x minus 1. Okay, great. We have the same base. These can go away. And now we're just going to set our exponents equal. So we're going to do 3x minus 1 equals 3 times 2 over 3. Okay. Now, some people are like, this is throwing me off, right? Every whole number has what underneath it? What can I put underneath the 3? Oh, thank you, Steph. 1, 1. Good. Yes. For my people that struggle with fractions, put that 1 under it. And then I always teach my kids, if you can get ready, like it's just going to save you a lot of headache. Because when we get to rational and we start factoring and crossing out, if you're good at just crossing out right away, it's going to save you, especially in algebra 2. So what do I mean by crossing out? Well, 3 divided by 3, those cancel each other because 3 divided by 3 is 1. So this and this goes to a 1. So really we have 1 times 2 and then 1 times 1. So 2 over 1 is just 2. And then we have 3x minus 1. Any questions just on this part? Or you could have looked at this as 3 times 2 is 6 over 3 and got 2 that way. Both ways will get you there. Oh, you can't see it. Naya, can you go over quadratic equations? Yes. Are you guys graphing them? What you doing with them? Are you guys solving them? Thank you, Mom. Yep, you're welcome. Can you do that with any other problem? Yep, Like, what you mean, Justin? Like, what you mean, can we do that with any other problem? Thank you for the double taps, you guys. The 6 divided by 3? Yes. Yeah, because you're just multiplying fractions. When you multiply fractions, you always look to see if you can cross simplify and then multiply. That way you're not reducing your fraction 1,000 times afterward. It will save you a lot of headache. So now we're going to solve this. We're going to add 1 to both sides. And we get 3x equals 2 plus 1 is 3. All right, those last steps, divide by 3, and x equals 1. All this hard work, right? Just for an easy one. It's not right. How would you solve if the 8? Okay. So how would you solve if the 8 was a 7 or something? So that would require, Bridget, that will require logs. Are you in logs, Bridget? Have you guys gotten to logarithms yet? Because that's how you would solve it if it didn't have like the same base. Like you couldn't come up with the same base. Then that's when you do logs. Yep, we got the x by itself. X equals 1. Now said, I need the basic math. No, now you're doing it. All right, so let's keep on going, you guys. Let's now we're gonna do the powers with different bases. Okay, so powers with different bases. I mean, really, that's what we were doing. But now we're doing multi-step equations. All these were 1-step, 2-step equations that we started with. Now we're going to move into multi-step equations, okay? So let's go here. So we have 2x to the plus 5 equal 2. Now what power do we need up here to get to 4? How many 2's do we need? 2. Good. Nell said 2. Steph said 2. J. Smith said 2. Yes, you guys. 2 to the 2. And since it already has that x there, you're going to just attach it to that 2. Because 2 times 2 equals 4. So since we have 2 2's, that's the exponent. Now that we have the same base, we can set these equal. So x plus 5 equals 2x. Well, what do we have to do first? What do we have to move first? If we want to solve for x. This is it called simplifying? I think, no, it's just called exponential it's like solving exponential equations. So minus x, good. Yes. So we're going to minus an x to both sides. We're going to drop down our 5 equals 2x minus x is x. So x equals 5. This part right here is just solving equations, which you really go hard in Algebra 1. And a little tiny bit in Algebra 2. Good, Mom. Why is it 5? Andrea, welcome back, hon. It's 5 because once we minus the x, we just drop down. We drop down the 5. And then 2x minus 1x is just 1x. Okay. Let's try this one. So we're going to drop down our 3, 2x minus 1. Okay. That's 2x minus 1 equals. Now this is kind of leading us to what we have to have on this side. A 3. Now this is the challenging part for some. How many 3s are you multiplying to get to 27? How many 3s? Let me see your answer in the chat. 3, 3, 3. Let's go, you guys. Yes, 3. So we can't do 9 here, because let me explain. If we do 9 here, we're saying 3 times 3 times 3, and we will go all the way times 3, all the way up to 9 would be too much. But 3 times 3 gives us 9 times 3 gives us 27. So it actually takes us 3 3s to get to 27. So you might have been thinking about this. Well, 3 times 9 gets you 27. But remember, we're dealing with exponents. So that's why you have to do it like that. I hope that clears that up for you, okay? So now that we have the same base, let's write this equation. 2x minus 1 equals 3x. What we move in first? Is it 3 to the 1? Good. Oh, okay. Good. Lulu, I hope you got it. Then minus 2x. Good. Yes. See, we want to move this 2x to the side. We don't want to move the 1 because there's nothing that we can combine this negative 1 to on this side. So that's why we're going to subtract 2x. Then we're going to drop down our negative 1 equals, well, 3x minus 2x gives us 1x. Good. And I saw those negative 1s coming in. Now let's make sure it actually makes sense, right? Does that actually work? Oh, yeah, it does. Let me show you why it works. So, because I was like, does it work? Is it looking right? But let's check it, okay? Let me do this. So let's check our work. So if we plug in 2 times, we got a negative 1 for x, minus 1 equals 27 to the negative 1 power. Okay, it's looking kind of crazy right now. But 2 times negative 1 gets us negative 2 minus 1. Okay, 27 to the negative 1. Negative 2 minus 1, somebody owes you $2. They say, let me get one more. Well, that's going to be 3 to the negative 3 power. I still don't see it. This does not look the same, right? It does not look the same. But again, remember, if we change this 27 to the same base as this is 3 to the positive 3 times this negative 1 that they already had. Oh, starting to look like a little magic. Okay, so 3 times negative 1 gets us negative 3. Boom. These are the same. Any questions? Any questions just on that? No? Okay, good. All right. Okay, we'll keep it pushing then. Fantastic. Okay. So let's go to number 2. Thank you for the double taps. Thank you, Ashley, for sharing the live. Can we get to 4K double taps before we move on, you guys? Can everybody take a second to double tap their screen for me, please? Thank you so much for gifting me, Anastasia. Thank you. For the heart fingers. Thank you. All right. We are at 4.6. Thank you, guys. Let's continue. All right. So we have 3x minus 1 equals. Okay. This is really telling us what the base is. So now we have 2. Okay. Again, how many 2s does it take to get you to 4? Let me see it in the chat. Yes. Oh, thank you, Jars. Thank you, thank you. Good. 2, 2, 2. Yes, it takes 2 2s. Remember, it already had an X here, so we have to just attach it. Now that we have the same base, I'm like, is this the same one? But no, it's different. Okay, so we have 2. Oh, we're going to have 3x minus 1 equals 2x. Okay, this is a 3, you guys. What we move in first? If we want to solve this one, what are we going to move? The 3x, move it? Okay, I'm down for that. Good. So we're going to subtract 3x. Beautiful. To both sides. And we're going to drop down our -1 equals 2 minus 3. 2 minus 3 gets us a negative x. Last step. Let me see it in the chat. What's our last step? Thank you for getting the heart me, Kay Allen. Thank you, thank you. What is our last step? Andrea, -1. Good. What we doing with it? Bridget said divide by -1. Good. Now we can multiply by -1 too. We can. Beautiful. So we could multiply or divide. And we would get x equals 1. Good. All right. Okay, perfect. Okay, so now we have 3x plus 1 equals 3 to the what power here? What am I putting up here if I want to get to 9? How many 3s does it take to get to 9? Thank you for the gift. Thank you, Lala. 2. Good, you guys. Yes. 2. Now, what do I write? Okay, this is a question. Can I write this like this? 3 to the 2, x plus 3. Can I write that like that? Or do I have to write it as 3 to parenthesis x plus 3? Put 1 in the chat or 2. Which one is correct? 1 or 2? Good, Bridget. Yes, 2. Good, Billy. Steph. Yes, Angie. Good, Alex. Good. Okay, number 2 is correct because remember, this is already up here. So when we change the 2, we're multiplying. So you're saying, well, you didn't put a parenthesis here. I did not, because it was only one thing. Only an x. But as soon as they put that plus 3, you have to use parentheses. Okay? Because you're really what we're going to be doing, and I'll show you that on this next step. 2 parenthesis x plus 3. Remember, that means we're going to distribute. Boom. Can you guys show me the distributive property? What are we getting on this side? Two x plus 6, 2x plus 7, 2x plus 6. Yes. Okay, 2 times x is 2x. Don't forget here, we're multiplying. 2 times 3 gets us a positive 6. And then we have x plus 1 that we're going to drop down. Good, you guys. All right, what we moving next? What do you guys want to move next? What should we move next? We're right here. Angie said -1 to both sides. Angie, I'm right with you. Okay, so we're going to -1 first, because that's what I saw first. And we get x equals 2x plus 5. All right. Thank you for the gift. Goat Life, thank you, thank you. Goat Life, you always be supporting me. I just want to say thank you so much because I do be seeing your likes on my videos. So thank you. Okay, if we minus the 1, which is nothing wrong with that, what do we have to do next? Does anybody know? Thank you, Steph, for liking. Thank you, Final. Welcome, Lex and Liz. Move the x, -2x. Good, minus an x. Now, if we, technically, there's nothing wrong with minus an x, but then you would have everything to one side. And we want the x's on one side and the numbers on the other. So that's why we're going to minus the 2x. And then 1 minus 2x gives us a negative x equal to a positive 5. Divide, and we get x equals -5. And that's our beautiful answer. Thank you for the finger hearts, Goat Live. How is that? How is what, Andrea? 1 minus 2x is a negative x. Because it's like you starting off with $1 and then you spend 2. Well, you're going to owe 1. By us choosing to move the -1 first, it forced us to move this positive 2x to this side. We could have moved the x first and then wouldn't have had a negative to deal with. Yes, it did add an extra step. You're 100% correct. But some people see it like that, so no worries. Thank you, Ashley, for sharing the live. Thank you for the double taps. We're at 10K.5. I appreciate it. Thank you for all the comments. We're at 23 finger hearts. Thank you, you guys. We're almost halfway to our live goal. So thank you, thank you. All right, let's keep on pushing. So we have 2x plus 2. Now remember, we were working on this. If you've been here from the beginning, how do we write 1/2 as a power of 2? 2 to the what exponent? Can I see it in the chat? 2 to the what? What number is going up there? Billy, let's go. Nell, yes. BW, yes. Jars, thank you for the double taps. It's a -1. Beautiful, you guys. Because remember, this 2 down here is to the 1 power, right? So when we move it up, it goes to a -1. Now we have an x, but it doesn't have no plus anything, so we could just attach it, okay? And now that we have the same base, beautiful, you guys. X plus 2 equals a -x. All right, what we moving? Hey, Perez. I hope you're having a wonderful Wednesday. Steph said we moving the x. Beautiful, Steph. Yes. So we're going to minus x. And then we get 2 equals. Now, what am I writing right here? Am I just writing x? Billy said negative 2x. Philly said negative 2x. Let's go. Yes. Remember, this is somebody owes you $1 and they say, let me get another one. Well, they're going to owe us $2. So negative 2x. We want to get x by itself. Remember, whenever a number's attached to a letter, they're multiplied together. To undo that multiplication, divide. And we're going to divide by what's attached to the x. That's why we're dividing by negative 2. And x equals 2 divided by negative 2 is a negative 1. And that's our beautiful answer. This one is looking too crazy. Okay. That one might send me over. Oh, good, Billy. Oh, good. So you guys did it in class? Is this what you guys are working on, or are you guys going to logs right now? Good, Perez. All right. So we have this. Number 7, we have 4x plus 1 equals. Now, I'm going to keep this the same base. So I'm going to do, ooh, can we? Is there 4 to any power that can give us an 8? That's the question. Is there 4 to any power that can give us 8? Yes or no? No, no, no. Yes, you guys. Ellis, yes. So no, so that means I really do have to change this, unfortunately. So I have to go 2. So 2 to the what power is going to give me a 4? Hopefully you're saying 2. Remember, I have x plus 1 up here, so I have to use parentheses. And then equals 2 to the what power? Let me see your answers in the chat to make 8. Good, Ellis. Let's go. 2 to the 3rd. Yes. And then put that parenthesis, x minus 1. Beautiful. Okay. Now we have the same base. So we're going to set our exponents equal. So 2 times x plus 1 equals 3 times x minus 1. Can you guys distribute this side for me in the chat? And I'm going to do this side. So 2 times x is 2x. And 2 times 1 gives us plus 2. What do you guys get? Good. So Ellis said 3x minus 3. Leah, 3x minus 3. Beautiful. Mad said 3x minus 3. Steph, now let's go. 3x minus 3. Beautiful, you guys. Okay, here comes our multi-step. What are we moving first? Oh, it's making me reset, you guys. Hold on just a second. The 2x. Ellis, now I'm with you on that one. Good. We're going to move the 2x because I don't want to deal with a negative. So I'm going to minus 2x and minus 2x here. I'm going to drop down this 2 that I did not use. 3x minus 2x is 1x minus 3. What am I doing? Okay, now what am I doing? Because I want to just say, what am I doing now? The 3. Lala, thank you for the follow. Add 3. Yes, Bridget, that's what I was looking for. Adding 3 to both sides. And then x equals 2 plus 3, 5. And that's our answer. Good. All right. Okay, let's go to this next one. So we know 9. Let me explain why we know 9 is not going to be our base now. Because if I do 9 over here, there's 9 to nothing power that can get me 27. That's how come I know I have to make this smaller. Okay? Does that make sense, you guys? So there's nothing 9 to no power that can get it to 27. So we have to go to 3. And 3 times 3, that's 2 3s, is going to give me 9. So 2x minus 1 equals 3 to the third power. And then that's going to give me x plus 1. Okay. Now that we have the same base, we can set our exponents equal. So 2 times 2x minus 1 equals 3 times x plus 1. All right. Can you guys distribute this side in the chat while I do this side? So we get 3 times x is 3x. And then 3 times 1 gets me plus 3. What do you guys get? Good, Billy. 4x minus 2. 3, 4x minus 2, 4x minus 2. You guys are on it. Yes. Good. So 2 times 2 is 4. So we have 4x. And then 2 times a negative 1 is a minus 2. Perfect. What are we moving first? Thank you for the follow, Katrina. Thank you. Minus 3x. Yes. Dior. Ellis. Good. So we're going to minus 3x. And then 4x minus 3x is just x. We're going to drop down this minus 2 that we didn't use and the 3. We add 2, and x equals 5. This is when the panic starts to sit in, right? If this was a test and we got 2 of the same answers, that's when the sweat starts to come like, oh, am I doing it wrong? Am I doing it right? The panic, not the same answer. If you know, you know, right? Can you do solids or revelations with disc and washer? You know what? Because I taught, I used to be a beast with calculus. I used to be in the math lab at my community college, teaching and doing all that, coming back. And then I got my teaching degree. My teaching license. And I only taught algebra and geometry for the last 7 years, and algebra 2. And now all my calc skills, they are rusty. Thank you so much for the gift. But I think I just saw AMT up on here. Hey, AMT. AMT, go check him out because he does calculus. Doing good. Oh, I just wanted to say congratulations. I saw you made your goal on YouTube. You're inspiring me, okay? Let me just say that. I'm pushing on YouTube now too, so congrats. But AMT is posting. He does calculus. So somebody just asked for washer. Put it in the chat again. And then maybe he can do a video. Or if you're looking for tutoring, hit him up. All right, number 6. Let's go to number 6. But anything else? Again, if you need help, you can email me at impactmath19@gmail.com. And if you want to watch this live again, it will be on my YouTube page at impactmath19, okay? Over there. All right. Okay, let's get to it. Now, this is a prime 3, so we're going to leave this 3x plus 5 equals 2. 3 to the... Now, we're asking ourselves, how many 3s hi, are you going to multiply to get to 27? 3. I think we did this one, didn't we? Let me make sure we didn't do this one. Oh, no, it looks very similar, though. If you were here from the beginning or like midway, remember we saw this 2/3. It's not going to scare us anymore because we know it's going to happen, right? So it's 3 to the 3rd times 2/3. We have the same base. So we have x plus 5 equals 3 times 2/3. Every whole number can be written over 1. Remember, I always teach, let's start crossing out, especially when you get to, in Algebra 2, you're going to be doing this when you get to dividing rational polynomials. I don't know if you guys already got there, but you know how you have to like cross simplify once you factor it all down and start crossing out stuff? This really helps. Like if you could just start seeing it in this simpler form. So 3 over 3 goes to a 1. And then we have 1 times 2 is 2. And 1 times 1 is just 1. So we're just going to leave that as 2. And then x plus 5 equals 2. Last step. Remember, this is addition. So we have to subtract. Put in the chat, what is your answer? Put it in the chat. What did you get? Yeah, thank you, Bridget. Yep, that's exactly where I got this one off of. -3. Perfect. -3. I just Googled exponential equations, algebra 2. This thing was like 44 pages. They had exponents. They had the square roots. Solving square roots equations. They had a whole thing with it. So if you just search this up, exponents, equations, I think it was like the 3rd one, algebra 2. All right. Okay, we're getting closer to this nightmare one, right? That's what I'm going to call it. Okay. 25. 5 to the what power? Let me see it in the chat. If we want 25, it's going to be 5 to what power? It was just Google. Judah. 2. Good. So 5 to the 2. Remember, we have 2x minus 1, so we have to use parentheses. 2x minus 1 equals 5x plus 3. Perfect. We have the same base. We're just going to write these exponents the same. All right. Can you guys put this part in the chat for me? What do you get when you do this? Yep. Good. Ellis. 4x minus 2. Dior. How do the exponent base disappear? That is the exponent rule. Good. So we get 4x minus 2. That's the exponential rule that says whenever you have the same base, you can set the exponents equal. It's like a theorem and a rule that's why we're allowed to do that. Great question. Minus x minus x. And 4x minus 1x gives us 3x. Minus 2 equals 3. We're going to add 2 to both sides. And we get 3x equals 5. Ooh. Yeah. What are we going to do next? Yep. See, I got my little singer in the background. Divide by 3. Perfect, you guys. Divide by 3. Divide by 3. And we get x equals 5/3. Okay. Huh? No. All right, so let's finish with number 10. Whew. This nightmare of a thing, right? Now, how we want to do this? I think what I'm going to do is, this is what my brain is telling me, is you see this extra 2 out here and this 8? I'm going to divide this by 2 and this by 2. So this 2 can cancel, and then I'm left with 2x minus 1 times 4x plus 1. Okay? Equals 8 divided by 2 is going to give me 4 times 16x 1 minus x. Okay. How did that help me, right? Okay, now there's a rule in exponents that say when you multiply exponents, right? You can add, when you multiply with the same, when we multiply, we add, like, so this is what I'm saying. If we have x to the second times x to the third, right? We can add the exponents and get x to the fifth. So if I rewrite this as 2x minus 1 times 2 to the 2x minus 1. Okay, so I can create the same base. So I did 4 to the second power. Now I'm going to use this rule here. I'm multiplying with the same base. So I'm going to write this as 2, and I'm going to add these exponents. X minus 1 plus 2x minus 1. Or 2 times x minus 1. Any questions just on this part? Let me look up. Hey, Jacinda. Hey, hun. I hope you're having a great Wednesday. Yeah, this is Algebra 2. This is them exponential equations that they was asking for yesterday. So the previous question in the 5 cancels out. Yeah, once you have the same base, you could just set the exponents equal. The 5s go away. Yes, Jacinda, I gotta keep on working on them. I'm gonna keep on working on them. Where did the 2 come from? So Angela, I changed this. I put the 2 here, and I said, well, how can I make 4? By doing 2 times 2. So I put 2 to the second power. So 2 to the second power is 4. And then I attached the x minus 1 to it. Oh my goodness. Thank you guys. Jacinda, thank you for the finger hearts. Give it to him. Thank you so much. We're halfway to our goal, over halfway. I appreciate it. Okay, so now we have 4, right? So we need the same base. So we're going to make this 2 to the second times 2. Now, how many 2's are we multiplying? Let me see this in the chat. How many 2's do we have to multiply to get to 16? That's the question. Good. Ellis said 4. Michael said 4. Let's go, you guys. Steph. Yes. 2 to the 4th power. And then we do 1 minus x with parentheses. Okay, we got the same. We're multiplying with the same base. We're using this rule here that says if we multiply, we get 2. And we're going to add these. 2 plus 4, 1 minus x. Whoo, we made it, right? We have the same base. Now we can set our exponents equal. So we're going to do x minus 1 plus 2 times x minus 1 equal to, and we're going to write this, 2 plus 4, 1 minus x. All right. All right. We'll just take this step by step. We're going to multiply here. And I'm going to drop this down because there's no number attached to it. So I'm going to get rid of the parentheses and just drop it down. X minus 1 plus. Actually, can you guys put this in the chat? What are you getting when you distribute here? Put it in the chat. And I'm going to distribute this side. 4 times 1 gives me 4. 4 times negative x gets me a negative 4x. Good. 2x minus 2. Yes. Beautiful, you guys. 2x minus 2. Remember, you multiply here, okay? Now, let's clean it up a little bit. Or I should say a lot of bit, right? You got those that are like terms. What else we got is like terms? And we got this and this that is like term. So 1x plus 2x gives us 3x. And then negative 1 minus 2 gets us a negative 3. Equals, am I still on the screen? Sorry, am I still? Are you guys good? You guys can see it? Thank you for the follow. Thank you. Heidi, good. And then we have here, I don't want to use that color. These are like terms on this side, right? 2 plus 4 gets us 6 minus 4x. What do we do next? What are we moving? Okay, so 4. Oh, but don't forget to add that 2 with it. Just in the, yep. So minus 3x. Okay, I saw minus 3x, but I'm actually going to add the 4x because I did see that as well. Well, I'm running out of space. So I'm going to move it over here, you guys. Okay. So we'll do this. Boom. So 3 plus 4 is 7x. We're going to move that negative 3 here equals 6. Now we're at a 2-step equation. So we're going to add 3, and we get 7x equals 6 plus 3 is 9. And then divide by 7, and x equals 9/7. This is looking too ugly. I don't like it. I wonder if I couldn't do this. Let's check it, you guys, real quick. What time is it? Let me see. Make sure I'm not, if I have time to check it. Let's just check it real quick before I have to jump out of here. Let's see if we got it correct. I believe we should have, but you never know. I'm human. Thank you, Jacinda. Thank you. Okay, so let's check it. So we're going to plug in our answer, 9/7, into there and see if we get it. So we have 2 times 2, and then I said 9/7. 9/7 minus 1 times 4, 9/7 plus 1 equals to 8 times 16 to the 9/7 minus, oh, no, to the 1 minus 9/7. Okay. Ooh, this is so ugly. So we're going to do, I'm going to just take it step by step. Okay, you guys? Let's take it step by step. Oh, can you guys see it okay? Let me make sure you guys can see it okay. It's kind of high. Okay, let me put it down a little bit. Okay, perfect. All right. So let's do a little side work or some work down here. You know, when you're doing 9/7 minus 1 over 1, remember, you have to have the same denominator whenever you're subtracting fractions. So if we multiply this by 7 over 7, then we'll get 9/7 minus 7 over 7. Okay? So 9 minus 7 is 2/7. So this is going to go to 2 times 2 to the 2/7. Okay. Times 4. Now let's go here. Here we have 9/7 plus 1. Remember, that 1 is going to be 7 over 7. So that's why we're doing 7 over 7. Well, 7 is going to stay the same in the denominator always. But 9 plus 7 is going to give us 16/7. So we're going to get 16/7 here. Okay. Okay, so now let's keep on going. Okay, let's keep on going. Let's hope something looks good over here. Okay, so now, remember, if we could change this 4 to the same base, let's get all our things to base 2. So this will be 2 to the, how many 2's are we multiplying to get to 4? Hopefully you're saying 2. Okay. And then we're timesing that by 16 over 7 times 2. And it would be easier if we had a calculator, right? Times 2. Remember, there's always a 1 up there, okay? Okay, now let's go over here. This is going to be 2 to the 3rd power. We have 1 minus 9/7. Let's do this down here. So remember, 1 minus 9/7. We need this to be the same denominator. So again, we're doing 7 over 7. 7 minus 9 is going to give us -2/7. Okay, we like that. Okay, so now 16 is going to be 2 to the, how many 2's is it taking us to get to 16? Well, it's taking us 4 2's. One more 2 then to get to 8, because 8 times another 2 gets us 16. So it has to be 4. And then we're going to times that by -2 over 7. Okay. So let's clean this up a little bit. Okay. So now we have 2 times 16 is going to be 32, because 16 doubled is 32 over 7 times 2 to the 2/7 times 2 to the 1. Okay. Equal to 2/3 times 2. Well, 4 times a -2. Remember this over 1. 4 times a -2 is a -8 over 7. Okay. So it's still looking real ugly, right? Now, when we multiply exponents, we add their bases. So really, we're saying 1 plus 2/7 plus 32 over 7 is equal to 2 minus 8/7. It doesn't work, right? Am I tripping? Because this is minus and then this is a positive. So how are they gonna come out the same? It's not. It don't check. Where did the 3 go? Was there a 3? Isn't it 3? Where's 3? Where am I tripping? Am I tripping? Where? Oh, on the right? Left, right? Okay. Oh, thank you. You just saved me. Ego. Thank you. Because this is supposed to be a 3 right here. Thank you. That's what it's supposed to be. 3 minus 8 sevenths. Okay, I'm going to just keep on going. But it's still not looking good, y'all. Okay, so we got 1 plus 32 plus 2 gives us 34 over 7. Equal to, see, that's why I'm saying it's not going to, because this is 3 over 1 minus 8 sevenths. And then we have to times this by 7 and times this by 7, right? And this, so this will be 21 over 7 minus 8 sevenths. Nah, it's not working. Because then this would have to be 7 over 7. This number going to be way bigger than this. We got to save it for another time, y'all. So scratch that last one. Wait, so he says 2 and 41 7 does not equal 1 and 6 7. So 2 and 41 7 does not equal to 2 and 13 7. Nah, it doesn't. Yeah, but see, I'm trying to show that this side equals this side, and it's not true. Whew, y'all, that was some crazy stuff. So I'm gonna do this one. I might have jacked up when I divided by 2 here. I should have left this instead of dividing by 2. I'm gonna try this problem again when my brain is more fresh. And then one, it has to be more fresh, right? So I'm gonna try it without dividing by 2 because I think that's where I made a mistake. You can't do that. So fix. I'm gonna fix this. So don't look at number when I repost it. You guys go hear this conversation. We need to fix this one. Yeah, Bridget said it's okay. Good job, everyone. Yes, great job, everybody. Thank you. Heidi said when I divided by 2, I had to, if I was gonna divide by 2, it has to be divided by everything by 2. But I can't divide these exponents by 2. So thank you, Heidi. That's where the original mistake was. Beautiful. All right, you guys. Have a wonderful, amazing day. And I most definitely will catch you on the next one. Bye, everyone.